Here are the video solutions for NCFE Level 2 Maths. This is section B, this is the calculator part, and this is September 2020. So the very first question, we are comparing crime rates for the UK and Oldcastle. Now, the ratio of solved to unsolved is 2 to 9. So what that means is that 2/11ths are solved and 9/11ths are unsolved. And we're dealing with 11ths because 2 plus 9 is 11. So in Oldcastle, that means 2 out of every 11 are solved. What is if I was comparing 2/11ths to 1/8? So first of all, actually, let's go back a step. So Oldcastle is 2/11ths and the UK is 1/8. So what is better, 2/11ths or 1/8? So what I would do is turn them into percentages. Now, to turn 2/11ths into a percentage, it's 2 divided by 11 multiplied by 100, and that is 18.18%. And for the UK, it's 1/8, so that's 1 divided by 8 multiplied by 100, which is 12.5%. So we can see that in Oldcastle, the solving of crimes is greater than it is UK. So is she correct? I can't remember if she said it was greater. Alice thinks that a greater proportion of crimes are solved in Oldcastle than the rest of the UK. Yes, she is correct. So you can just say yes, she's correct, because 2/11ths is greater than 1/8. So yes. Okay, part B. The value of items stolen in Oldcastle has increased by 8%. So in 2017 it was 1.7 million. So we want 2019. So we need to increase 1.7 million by 8% twice. Now the multiplier for 8% is 0.08. This figure here divided by 100, and we would use 0.08 if we wanted to calculate 8% of an amount. So if you wanted to calculate 8% of 1.7 million, you'd multiply 1.7 million by 0.08. So we could multiply 1.7 million by 0.08, and whatever the answer is, add it on. But there's a much easier way. If 0.08 is the multiplier to calculate 8% of an amount, then to increase by 8%, we just add 1 to this figure. So our multiplier is 1.08. So 1.7 million multiplied by 1.08, and we need to do that twice. So multiply by 1.08 again, or 1.7 million. Notice that I'll worry about the fact that it's million later on, by the way. 1.08 squared, and that comes to a total of 1.9828 million. It doesn't say how it wants it written, so you could always just multiply this by 1 million, which is 1 with 3 zeros. 1.98288 times 1,000,000 comes to 1982880, and feel free to put commas after every block of 3 going from right to left. So that is the answer to 2B. 2C, it's simply what are the coordinates of the point marked by X. So remember, we go along the corridor and up the steps. So we go horizontally, then vertically. So we're going horizontally to -3 and then up to 4. So it's -3, 4. Okay, part D. We want to work out the probability that a person has blonde hair and is under 5'10". So blonde and under 5'10" is 3. There are only 3 people, and that is out of a total of how many? So we need to add up the number of people. Well, actually, we don't need to add them up. We've been told there are 15. So as a fraction, it is 3 out of 15. Well, not unfortunately. We need to watch out though. This fraction can be simplified. We can divide the top and the bottom by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Now, what is that as a decimal? Well, if you like, you can convert fifths easily into tenths. We're multiplying the number on the bottom by 2, so do the same to the number on the top. So 2/10, so that is therefore 0.2. So question 2E. So we know that the scale of the map is 1 to 25,000, and the distance between gate A and gate B is 9 centimetres. So if the scale is 1 to 25,000, then that means 9 centimetres is going to be 25,000 multiplied by 9 centimetres in real life, and 9 times 25,000 is 225,000. So 9 centimetres on the map equals 225,000 centimetres in real life. So probably we want to turn this into meters. Well, we definitely want to turn it into meters because we want meters per second. So divide that by 100, chop off 2 zeros, so 2250 meters. Now we want to work out the speed. Now speed is the distance divided by the time. We know the distance is 2250. How long does it take? Well, we've been told that it was 12 minutes, but the speed we've been asked for is meters per second. So I need to turn these 12 meters into seconds. So 12 multiplied by 60, that is 720 seconds. So that's my final calculation, 2250 divided by 720 seconds, and that comes to 3.125 meters per second. Okay, 2F. Not too bad. We can see that this is a right angle, so therefore this is exactly 1/4 of the area of a full circle. Now the formula for the area of a circle is pi r squared, so we want 1/4 of that, so just divide it by 4. Pi is 3.14, so 3.14 times by the radius, which is 5 squared, so 5 times 5 divided by 4. That's our calculation, and that will result in an answer of 19.625 square meters. Okay, so for this question we just want to, we're sort of doubling these areas and we need to convert them into centimeters. So first of all, 5.5 inches, 5.5 inches, I would write that as 5.5, and 3 3/4, that is 3.75. We want to double each of them because we're doubling both the width and the length. So 5.5 times by 2 is 11, and 3.75 multiplied by 2 is 7.5. Now these are inches, and we're trying to convert these into centimetres. So 11 inches, that is going to be 11 multiplied by 2.54, which is 27.94 centimetres. 7.5 inches is 7.5 lots of 2.54, and that is 19.05 centimetres. So if we double it, this is what the dimensions are in centimetres. And will it fit onto a 21 by 29.7? Well, 19.05 is less than 21, and 27.9 is less than 29.7. So the answer is, will the enlarged picture fit onto one side of A4 paper? The answer here is yes. D. I don't think this one's so bad. We know that 8 volunteers, so I'll put 8V, take 480 minutes, and we want to work out how long it would take 12 people. So 12 volunteers take how long? Okay, well obviously if it was 16, that would be a nice number. That would be twice as many volunteers, so it would take half as long. Now what you could do is work out how long it would take one volunteer, and since these are both multiples of 4, I'm going to work out how long it would take 4 volunteers. So we've got half as many volunteers, so it will take twice as long, not half as long. Just because we're halving this number doesn't mean we're halving that number. This is indirect proportion, and just think of it logically. If you've got fewer people doing a job, it will take longer. So we've got half the number of people, so it will take twice as long. 480 times by 2 is 960 minutes. But if we've got 12 people, which is 3 times more people, it will take 3 times less, and 960 divided by 3 is 320 minutes. And we don't need to convert that into hours or anything, so there's our answer, 320 minutes. Okay, so question C. So the key thing is that the local business is donating 25 pence for every £10 that Sam raises. So that means for every £10 the charity is going to get £10.25 if we include the 25p that the local business is adding on. So what we want to do is work out how many £10.25s are in this figure here. So £2,634.25 divided by £10.25 is 257. So what that means is that Sam raised 250 lots of £10, and that comes to 2,570, and on top of that there was 257 times by 25 pence, and 200 times 25 pence is 6,425 pence, in other words £64.25. We might want to just add these up just to double check that we get to 2634.25, and let's just double check that. So 64.25 plus 2570 does indeed equal 2634.25. So how much did the business donate to Sam? Well, that was therefore the £64 and the 25 pence. So that is our final answer. Okay, for question 3a, the key thing is we need to put this number here into words. So we need to remember that words like 1,000 are often represented by commas. So usually it's just a case of writing down or reading 3-digit numbers and then saying words like 1,000, million, billion, etc. I'll show you what I mean. So we've got here 569, so 1,000. So let's just write 569. The 1,000 is a comma, and now we're writing another 3-digit number, 801. So 569, 801. So we can see that that is a 6-digit number that is between this 6-digit number and that 6-digit number. So therefore, it is a medium category. Okay, so for this question, Chad aims to raise £626,000 and 21% is grants. So what is 21% of 626,000? Well, the calculation for this is 0.21 multiplied by 626,000, and this 0.21, this is the percentage multiplier for 21%. It's this number here divided by 100, and 0.21 times by 626 is 131,460. So of the total, this is the amount they expect to receive, but they have already received £95,280. So what we need to do is 131,460 minus the 95,280, so we can work out the difference, which is the shortfall, and that comes to £36,180. So for this question, we've got a table of values for one-off donations, and we've got some facts about regular donors here, and we want to work out which mean was greater. Now what we've got here is, well, for the one-off donations, it's not going to be an actual mean, it's going to be an estimated mean. We've got 48 people that donated between £0 and £20. Now they might all have donated £20, or they might all have donated 1p, we'll never know. So what's the best thing we can do is just assume that all 48 of them donated £10, which is halfway between 0 and 20. So I'm going to create a column here, MP, for the midpoint of these ranges. So 0 and 20 is 10, 20 and 40 is 30, 40 and 60 is 50, 60 and 80 is 70. And what I'm going to do here is work out a total. Sorry, I shouldn't have gone into this line here, but I don't really have much option here. So we're assuming that these 48 people donated £10 each, so therefore these 48 people raised a total of £480. So when you're working out an estimated mean, and it's always an estimated mean when you're dealing with ranges, you want a midpoint table and a total or a frequency times midpoint column as well. It helps if you understand why we're doing this, but if you don't understand why, just learn that you need to write down the midpoint and then frequency times midpoint. 146 times by 30 is 4380, 74 times 50 is 3700, and 32 times 70 is 2240. So the total raised is all of these added together, which comes to £10,800. So for the one-off, the mean is going to be, running out of space here, it's this amount here divided by 300. So I'll just write this here, 10,800 divided by 300 and that comes to £36, and I'll note that that is for the one-off donations. And for the regular, it's going to be 7,500 divided by the 150 regular donors, and that comes to £50. And so this is regular. Sam says the mean amount donated last year was higher for the one-off than for the regular. Well, that is not the case, because we can clearly see that 36 is less than 50. So all these workings that I've done up here probably should have been done down here in the box, but scrolling up and down would have been a bit of a pain. But the answer after all of that is no. Okay, so Kay must raise funds at least 3 2/5 times her salary, and Mo must raise funds of at least 10/3. The question is just, what is larger, 3 2/5 or 10/3? Well, first of all, let's turn 3 2/5 into a top-heavy fraction. That's going to be 3 lots of 5 plus 2. 3 5s are 15, 16, 17. So what is bigger, 17 over 5 or 10 over 3? Remember that the line of a fraction means divide. 17 divided by 5 is 3.4. 10 divided by 3 is 3.3 recurring. 3.4 is greater than 3.3 recurring, so therefore 17/5 is greater than 10/3, so therefore 3 2/5 is greater than 10/3. So the answer is here 3 2/5. So for this question we need to work out the percentage discount. Well, first of all, what is the discount? Well, the discount is 15,400, take away the 13,500, so that comes to 1,900. So the discount is £1,900. So we just need to work out, well, what is this as a percentage of that? It's just the difference divided by the original amount multiplied by 100. That's how we work out a percentage change or a percentage discount or percentage profit. The difference divided by the original times by 100. So it's 1,900, that's the difference, divided by what it was originally, 15,400, multiplied by 100, and that comes to a total of 12.3376%. We want one decimal place, so we're interested in the value of the second decimal place, which is a 3, so that will round down to 12.3%. So Emma's offering to buy the car, and she's using this formula here, 12,000 times C times 0.75 to the T. T is the age of the car in years, so T equals 3, and C is the condition of the car, and it's in good condition, so C equals 0.9. So our calculation, if I can find somewhere to write it, I'll just scribble it here, 12,000 multiplied by 0.9 multiplied by 0.75 to the power of 3, and that comes to a total of, let me just scroll up a little bit there, that comes to a total price of 4,556.25. Okay, that's what Emma is offering, and the question is, how much more could Bill get if he sells his car online? So Emma is, right, let me just note here, Emma's price is 4,556.25, and that's for a 3-year-old car. T is 3. Now, if he sells it online, he could get a minimum of, well, clearly over 8,000 and a maximum of getting close to 10,000. Well, what exactly are these values here? We're going up in 2000s, and there are 5 lines between each 2000, so we're going up in 400s. So he could get a minimum of 8,400 and a maximum of 9,600. So how much extra could he get? Well, let's just go off the minimum price. You could get, it doesn't matter, you could use the maximum as well, but I'll just use the more conservative of the two. What is 8,400 minus £4,556.25? And that comes to a total of 3,843.75. So this is the minimum extra he could probably get if he were to sell it online. So there we go, 3,843.75. Okay, and on to the final question. Emma employs Hans. Hans gets a bonus of 1.5%, and we've got these makes of cars and some prices. And how many cars would Hans have to sell at the modal price to get a bonus of at least £7,500? Well, what is the modal price? The modal price is the price that pops up the most, and as we can see, 15,800 pops up more than any other, so the modal price is 15,800. There we go. So let's just clean the question up a little bit, and the bonus, let's just remind ourselves, is 1.5%. So what is 1.5% of 15,800? Well, our calculation is 0.015 multiplied by 15,800. And if you're not sure where this number comes from, if you're trying to work out a percentage of a total, we need a percentage multiplier, which is the percentage amount divided by 100. So that's where the 0.015 comes from. And that comes to a total of £237, and that's the bonus he gets per car. So how many cars would he need to sell to get to make 7,500? Well, how many 237s go into 7,500? In other words, what is 7,500 divided by £237? And that comes to a total of 31.64. Do we round up or down? It's not about whether this is closer to 32 than 31. It's about just thinking about the question. Well, if he sells 31 cars, he's going to be under the £7,500 bonus. But if he sells 32 cars, then he will get, well, it'll be more than 7,500, but at least that is at least 7,500. So just be careful with questions like that, whether to round up or down. So here the answer is 32 cars, and that is the end. Okay, so for question 4C, what we need to do is work out the total cost of fuel that Bill uses per day. Now, the fuel consumption is 16 kilometres per litre, and we know that he drives 45 miles every day. So what we need to do first of all is use the conversion graph to convert 45 miles into kilometres. So we've got miles along the bottom, kilometres up the side, so 45 miles is here. Let's just go up until we hit the line, which is here. It looks like it's one square above the 70, so it's a lot easier if you use a pencil and a ruler, and the examiners will be expecting to see these lines. So we're going up in 2, 0, 2, 4, 6, 8, 10, so this is 72 kilometres. So 45 miles, that is 72 kilometres. Now, for each litre, the car can travel 16 kilometres. So if we're travelling 72 kilometres, how many litres of fuel will be used? So the question is how many 16s go into 72. In other words, what is 72 divided by 16? And the answer is 4.5. So 4.5 litres of fuel are needed to travel 45 miles, in other words 72k. Now we know the fuel is 136.9 pence per litre, so if we're using 4.5 litres, then that's going to be 4.5 lots of 136.9 pence, and that comes to 616.05 pence. So this is our answer in pence. I'll just write it down here. As I said, that's 616.05 pence. We want this, the answer, the question does say pounds to the nearest penny. So if I'm turning this into pounds, I need to divide by 100. And that's quite easy. We're just moving the decimal point 2 positions. So that will be 6.1605, and that is pounds. And if we're rounding to the nearest penny, we're looking at the third decimal place, which is a 0. So that will simply round down to £6.16, which is the final answer. So £6.16.